Hello student, as in the last lecture, we had started with the definite integration chapter where we took some example based on how to find the answer for the integration. As I told that simply what you have to do, you have to find your answer by your basic integration and don't write C as you clearly had explained there is no need of um, writing C as anyhow the C will get eliminated in the second last step. Okay, as I took 3-4 example which was based on the basic algebraical. Okay, and now we'll take some few example based on the types that you have to guess the proper type. So this all sums which we saw in the last lecture was based on the basic integration formula like x raised to n, integration of sine, cos, yes or no. So now we'll take special sums based on the special types, like you have to guess whether the particular sum it is from the type number 1, 2, 3, 4, 5. Okay, uh, almost we had did 8 9 types in the integration, so you must know to guess the types. Okay, if you are best in guessing that the particular sum it is based on so and so type, or a particular question it is from so and so exercise, the rest part it will be very easy for you all. Okay, so let's take some few example now. So here we have one example integration. Okay, 1 to 2, as here 1 is what lower limit and 2 is what the upper limit. 1 upon x square plus 6x plus 5. First guess the type, that is very important. As can I say this look like what, this function look like what, the pattern of the question look like the type number 1a formula, yes or no. 1 upon quadratic form, it is in the form of what, integral 1 upon quadratic, yes or no. And we know that how to solve 1 upon quadratic. First we have to make the coefficient of x square 1 and the symbol should be positive. After that you have to apply the third term formula, yes or no. After that you have to apply the suitable formula, as we know that there are three formulas. One is 1 upon x square plus a square, the second one is 1 upon x square minus a square, and the third it is 1 upon a square minus x square, yes or no. So let's begin with the sum now. So I equals to 1 to 2, so 1 upon x square plus half into coefficient, it will be what, half into coefficient of x the whole square. So here you will get what, 2 ones are 3 is so 9 you will get. So you will add that 9 to the alphabet, yes or no, as per the rule, and you will subtract that 9 to the number, yes or no, as this whole thing we added in the integration. As I told also, the type number 1 will play an important role in many types, yes or no. So you must know to solve these types of sums. Okay, you must be comfortable in solving the sums based on the type number 1a. Okay, after this I equals to 1 to 2. Okay, so this, here we have plus and here also we have plus, so this we can write as what, x plus 3 the whole square. Here plus 5 and minus 9 we can write as minus 4 into dx, yes or no. As clearly we can see that this look like what, it is in the form of a square plus 2ab plus b square, which we can write as what, a plus b the whole square. Okay, as here the first and the second term both are what, positive. After this, as we know that even this 4 can be written as what, even can this 4 can be written as what, to the whole square into dx. Understood? Got the point? Okay. Now you have to guess the formula. Can I say this look like what? It look like integral 1 upon x square minus a square into dx, which is equals to 1 upon 2a log, yes or no, log mod x plus a. So here x minus a will come upon x plus a plus c. Okay. So now we'll integrate this part with respect to x by using this formula, that is integral 1 upon x square minus a square as 1 upon 2a log mod x minus a upon x plus a plus c. Okay, but here no need of writing plus c, as we know that anyhow in the second last step the c will get eliminated. Okay, so here I equals to 1 upon 2 into a. What is a here? It is 2 log mod, yes or no, x minus a x plus a. Okay, so here we'll write the upper limit and lower limit, yes or no. So I equals to, this is what, 1 by 4 log mod, so here it will be x plus 3 minus 2 x plus 1, and here it will be x plus 3 plus 2 5. Okay, now after this simply what we have to do, we know that simply replace the value of x first by upper limit and then by the lower limit. So here we'll write what, 1 by 4 will keep as it is log, if you want, as this 1 by 4 is constant. Okay, uh, and while putting the value, when you will replace the value of x by 2 and then by x by 1, for both the case this 1 by 4 will come. So if you want, you can bring this 1 by 4 outside the box. Okay, as anyhow it will be common for both the section. When you will put the value, like suppose if I have 1 upon a log, suppose here we have 1 upon c log x plus 1 upon x plus 2 b by a. So here you will write what, 1 upon c log, first you will put the value of what, b, yes or no, then after that you will put the value of a. Okay, so anyhow here 1 upon 2 will be common, so you can write 1 upon, sorry, 1 upon c will be common. If you want, you can write directly outside the box. Okay, in both the case you will get the same answer. So here also we'll do the same thing. If you want to write this 1 upon 4 outside the box, it is okay, or else straight away just replace the value of x first by 2. So here it will be what, 2 plus 1 will be what, 3, and 2 plus 5 will be what, 7. So here this part will be what, 3 by 7, yes or no, minus 1 upon 4 log, now we'll replace the value of x by 1. So 1 plus 1 is what, 2, and 1 plus 5 is what, 6. Okay, as here clearly we can see that 1 upon 4 is common. So inside the bracket box you will get what, log 3 by 7 minus log 2 by 6. If you want to cancel this number you can do. Okay, now after this Further, this can be written as what? Log, as this part it look like what? Log a minus log b, which we can write as what? Log a by b. Yes or no? Got the point? So this can be written as what? A by b. So 3 by 7 upon 2 by 6. Okay. So in the final step, this we can write as 1 by 4 log 3 by 7 into 6 by 2. Okay. 2 ones are 2 threes are. So therefore 1 by 4 log 3 threes are 9 upon 7. As here we cannot multiply or we cannot do anything. This is log part and this is the log x, and here we have the number, so we can keep the answer as it is. Okay, I hope you all understood the sum, how to track the sum. First, the very important thing is what? To guess the particular question it is from which type, and then after that see to that you have to integrate with respect to that, apply the suitable formula. Then simply we know that first upper limit will come and then after that lower limit. And here if you want you can bring this 1 upon 4, any constant it is there you can bring outside and simply put the value. Anyhow, in the next step, in the second last step, you will get here common, yes or no. So it is on you if you want to write this constant part outside and then substitute the value, or just directly substitute the value. Still in both the cases you will get the same answer. I hope you all understood this example based on the type number 1a. Okay, as here I have one more sum. Okay, so look like the previous one only, as it is in the form of 1 upon quadratic. Here just the changes was the upper limit and the lower limit. Okay, so here lower limit is 2 and here it is 3. In the previous sum it was 1 and here it was 2. So I hope this sum you can try by yourself. Okay, just see to that first make the coefficient of x square 1, and then after that apply the third term formula, apply the formula based on the type number 1a. Either it will be integral 1 upon x square plus a square formula will come, or else x square minus a square formula, or else 1 upon a square minus x square formula. As this all things I had explained when plus and minus symbol formula will come, and this when it will come whenever the coefficient, whenever the symbol of x square already in the question it says that it is negative, then only you will apply the third formula. Okay, so it is same similar sum almost. So the change is what? The upper limit and the lower limit. Okay, so please this sum you can try by yourself. Okay, okay, so here we have one more sum, that is I equals to integral 6 to 1 upon root 1 plus x plus root x. And here this side I have one more sum, integral 3 to 5 1 upon root 2x plus 3 minus root 2x minus 3 into dx. So whenever you come across sum like this 1 upon, you have 1 upon root a plus minus root b. Okay, so the first step will be what? Rationalize the denominator. Okay, rationalizing the denominator. As we clearly we can see that in the numerator here we have 1 and in the denominator we have both the term inside the root. Whenever it is inside the root, see to that simply rationalize. Okay, as in the first case this it is in the form of u by v, and we know that u by v rule it is not applicable in integration. So anyhow we have to convert this such types of question in such a pattern that after that we can apply the suitable formula, suitable concept to integrate the sum further. So whenever you come across the sum based on 1 upon root a plus minus root b, simply you have to rationalize the denominator. So we'll take this sum, and this sum please you try by yourself. So here the first step will do what? Will do the rationalize. Okay, here actually it is 0, 0 to 1, 1 upon root 1 plus x plus root x into rationalizing the denominator with the rationalizing means multiply the numerator and denominator by this section taking conjugate property. So if your plus is there, so here you will write minus upon root 1 plus x minus root x into dx. Okay, so after this 0 to 1, as when you will as here we have the relation, so when you will multiply 1 with this section, so you will get root 1 plus x minus root x upon, when you will multiply this two section, as this two part it look like what? A plus b into a minus b, which we can write as a square minus b square. Yes or no? I hope you all might be knowing how to rationalize the denominator. Whenever you rationalize the denominator, that denominator section it will get convert into a plus b and a minus b formula, so which we can write as what? A square minus b square. Yes or no? Now after this, integral 0 to 1 root 1 plus x minus root x upon the square root will get cancelled, so here will get 1 plus x. Here also square root will cancel, here will get x only. So therefore integral 0 to 1 root 1 plus x minus root x, here we can write this as 1 plus x minus x into dx. As clearly we can see that here x we can cancel this because it contain opposite symbol. The next 0 to 1, we left with root 1 plus x minus root x upon 1 into dx. So root 1 plus x minus root x upon 1, it is what? 1 plus x minus root x. Yes or no? Got the point? Okay, as here we have two term and it is separated with minus. So as we know that whenever inside the integral we have such format, we can separate the integral a into dx plus minus b into dx. Yes or no? Like suppose consider this a and b as two function. Yes or no? So this we can write as 0 to 1 root 1 plus x into dx minus integral 0 to 1 root x into dx. Okay, as just now in the last lecture only we saw whenever it contain root x, so we can write it as x raised to 1 by 2. So this part we can write as what? X raised to 1 by 2, and this part also we can write as x raised to 1 by 2 into dx. Okay, I hope you all understood till here. So whenever the pattern of the question is what? 1 upon, whether it is 2 upon, 3 upon. Okay, but see to it that in the denominator, if this pattern is there, both the term it is inside the root, and here we have plus minus. So see to that first step will be what? You rationalize the denominator by using conjugate property. After that you will get one part, separate the integral and then solve. So as clearly we can see that this look like, both section look like what? X raised to n formula. Yes or no? X raised to n is what? X raised to n plus 1 upon n plus 1 plus c, and this it is in the form of ax plus b raised to n into dx is ax plus b n plus 1 upon n plus 1 into 1 upon a plus c. Here we have to apply the chain rule. Okay, so this will be what? So when you will integrate, so here you will get what? 1 plus x raised to n plus 1 upon n plus 1 1 and 0, minus here also this will be x raised to n plus 1 upon n plus 1, 1 and 0. Here 1 upon, as per the rule, chain rule, into 1 upon a we have to write, as here the coefficient of x for this part it is 1, so 1 upon 1 it will be 1 only, yes or no? So that's why I wrote this step directly. Okay, if you want you can show this step. So here this will be what, 1 plus x raised to 3 by 2 upon 3 by 2. Here also x raised to 3 by 2 upon 3 by 2. Okay, so in the next step this we can write as what, 2 shift it to the numerator, so 2 by 3, 1 plus x raised to 3 by 2, yes or no? Here also we'll do the same thing, 2 by 3, x raised to 3 by 2. Okay, and out till here, understood? Okay, so now simply what you have to do, first you will replace the value of x by 1 and then by 0. So 2 by 3, first you will replace x by 1, so 1 plus 1 will be what, 2, so this will be what, 2 raised to 3 by 2. Then minus, then you will replace the x by 0, so 2 upon 3, 1 plus 0 will be what, 1, so here you will get 1 raised to 3 by 2. Okay, once again see, first you will replace the x by upper limit, so 1 plus 1 will be what, 2, 2 raised to 3 by 2. Then you will write minus, then substitute the second number, that is the lower limit, so 1 plus 0 will be what, 1, so 1 raised to 3 by 2. What the point here also, 2 by 3 into, first you will put 1, so 1 raised to 3 by 2, minus you will put what, 0 raised to 3 by 2. Okay, so therefore 2 by 3 into this 2 raised to 3 by 2 we can write as what, 2 raised to 3 by 2 as 2 raised to 1 upon 2 the whole cube, yes or no? And 2 raised to 1 upon 2 we can write as, we can write this as what, root 2 the whole cube. And root 2 the whole cube we can write as root 2 into root 2 into root 2. So further this we can write as 2 root 2. So remember, any number raised to 3 by 2 it can be written as that number into root. So this we can write as what, 2 root 2 minus 3 2 by 3 into 1 raised to any power will be what, 1 only, yes or no? Minus 2 by 3, this will be 1 only, and this part 0 into a number will be what, a 0. So the next step, this will be what, 2 upon 3 into 2 root 2 minus 2 upon 3 minus 2 upon 3. Understood? So the next step, 2 upon 3 into 2 root 2. Okay, as here clearly we can see that what, as here the denominator is same, so we can write the answer for one time, and minus 2 will be what, minus 4, yes or no? So in the next step, this 2 into 2 will be what, 4 upon 3 root 2 minus 4 upon 3. Okay, as in the next step 4 upon 3 is common, so we can write 4 upon 3 outside, and inside you will get root 2 minus 1. And further I guess root 2 minus 1 we cannot solve this part afterwards, so that means that's the end of the sum. Okay, so here the interesting and the important part is this section, when you will substitute the value, when you will solve this basic algebraical section, see to that it should be perfect. Don't do any mistake while solving the solving these steps. Okay, when you replace the value of x by upper limit and the lower limit, see to that it has to be perfect. Okay, and I hope you understood this sum also. So as here I took two example. Okay, one was based on what, just now only we saw one was based on what, type number 1, yes or no, type number 1. So simply here you have to guess the sum, that particular sum it is from which type or from which exercise, uh, and we have to apply which property. After integral, just simply for each and every sum we saw, simply what we do after integration with respect to x, simply you have to replace the value of x first by upper limit and then by lower limit, yes or no. Okay, so as we took 3 4 example in the first video lecture where we saw the sums based on the basic algebraical x raised to n. Okay, integral of cos sine, yes or no. Then here we saw one basic sum, and in this lecture video lecture we saw one sum which was based on the type number 1, and see to that it will not mention that the particular question it is from which type, that you have to guess by yourself it is from type number 1 or whether it is from that particular exercise 3.2, 8.2, 4.2, and then apply the suitable concept for that, apply the suitable integral formula with respect to x. Then simply you have to replace the value of x by upper limit and lower limit, and see to that you can bring this number outside and then you can solve, or else keep the number, substitute the upper limit and lower limit, still you will get the same answer. Okay, and then we took one more sum. Whenever you come across the sum like this, as this types of the sum it is there in the exercise, integral 1 upon root, when suppose both the term in the denominator, when you see inside the root, the first step will be what, remove the root from the denominator. So we know that there is only one concept, that is known as rationalizing the denominator. So from that you can remove the root from the denominator, and then after that we know that how to solve the integral, basic integral, by using x raised to n formula. Rest, after that we know that we have to simply replace the value of x by upper limit and lower limit. Okay, so in the next lecture we're gonna do many more sums based on the types. So as we'll take two example based on each type, there is no need of doing 10 example based on the type. As I told, 70-80% it is based on whole and sole integration. If you're perfect with your integration, so definite integration will be easy for you all. So we'll take two examples based on each type. One I will solve and second one you have to solve by yourself. Okay, so till then, goodbye, see you in next lecture.